This video is a short review of classifications of matter, as well as physical versus chemical properties and changes. First, matter is defined as anything that occupies space and has mass. That includes the air we breathe, books we read, water we drink and the glass we drink it from, and the helium that fills up party balloons. We can classify matter according to its state, which depends on the packing and movement of its particles. We can also classify matter based on its composition, what components make it up. Matter can be classified as a solid, liquid, or gas based on its macroscopic behaviors. Those behaviors are a result of the packing and movement of the particles of which it's made. We recognize an object as a solid when it has a fixed volume and a rigid shape. Those macroscopic behaviors are a result of particles that are packed very close together. The particles can vibrate in place, but they can't move past each other. If at the nanoscopic level the particles can't move past one another, then the macroscopic shape and volume of the object are fixed. Liquids have a fixed volume but not a fixed shape. This, again, is a result of the particle packing. Liquid particles are still very close together, but the little bit of extra space allows the liquid particles to slide past one another. So macroscopically, liquids can flow and assume the shape of their container. In gaseous matter, particles have lots of space between them. The particles are free to move pretty much independently of one another. Gas particles will spread out to fill up the volume of their container. A sample of gas has neither a fixed volume nor shape. Because of that free space between particles, gases are compressible, where solids and liquids are not. There's little to no free space between particles in a solid and liquid, so these states are not easily compressed. So we've just seen that matter can be classified as a solid, liquid, or gas based on the macroscopic properties it exhibits, including its density and the ability or the inability to change its shape and volume. Those macroscopic properties are a result of the packing and movement of particles. Also, you should already know that a material can change state with the addition or removal of heat. An object will change from solid to liquid to gas with increasing temperature. When the opposite happens, when heat is released by a material, it will change from gas to liquid to solid. We will discuss the connection between change of state and change in heat much more in a later video. In addition to labeling the state of matter, which is determined by the packing of particles, we can also discuss the type of matter based on the composition of the substance. In other words, this label is based on the identities of the particles present in a material. If a material has a definite and uniform composition, it is referred to as a pure substance. Every sample of a pure substance is the same. Its composition never varies. In comparison, mixtures are made up of two or more components in proportions that can vary from one sample to another. Pure substances can be further categorized into elements and compounds. This categorization depends on whether or not they can be broken down into simpler substances. An element is a substance that cannot be broken down into simpler substances. Sometimes, at this point in the discussion, a student pipes in with a comment like, "But atoms can be broken down into subatomic particles." This is true, but those subatomic particles are no longer unique objects. For example, although gold atoms and carbon atoms in lumps of coal are very different atoms from one another, the electrons, protons, and neutrons found within a gold atom are indistinguishable from the electrons, protons, and neutrons found within a carbon atom. An element is a substance that cannot be broken down into simpler, chemically distinct substances. A compound can be chemically broken down. It can be decomposed into its individual elements. Mixtures can be labeled as heterogeneous or homogeneous. A heterogeneous mixture is not uniform. Distinct regions can be seen in the sample. On the other hand, a given sample of a homogeneous mixture is uniform all throughout. A heterogeneous mixture is one in which the composition varies from one region of the mixture to another. Think trail mix, a salad, oil and vinegar salad dressing. Heterogeneous mixtures are made of multiple substances whose presence can be observed. Portions of a sample of a heterogeneous mixture have different composition and different properties. A homogeneous mixture is one made of multiple substances, but it appears to be one substance. All portions of a given sample have the same composition and properties. Think sweet tea. Every sip is the same. Homogeneous mixtures have uniform compositions because the atoms or molecules that compose them mix uniformly with one another. Any given sample of a homogeneous mixture is internally uniform. Two different samples made from the same components can differ from one another, though, based on the relative amounts of the two components. The sample of copper sulfate on the left in this picture is uniformly mixed. The sample on the right is too. The two samples are not the same as each other, though. They contain different amounts of copper sulfate for the amount of water present. So we see that elements, compounds, and mixtures vary in their physical and chemical properties. Let's talk about physical and chemical properties. A physical property is a quality that a substance displays without having to change its composition. These properties are easily observable. The odor something presents, the taste of a material, the color, the density, are all examples of physical properties. Melting and boiling points are physical properties too. When water boils, are you changing the internal structure of the water molecules in any way? No, the only change is the distance between the molecules. You haven't changed water's chemical composition, you've only changed the spacing of the particles. I can measure the boiling point of a substance without changing its composition. The temperature at which a substance boils, or the temperature at which it melts, is a physical property of that substance. A chemical property refers to a material's ability to undergo a particular chemical change. Is gasoline flammable? Yes. Is nitrogen gas flammable? No. That's a chemical property. Corrosiveness, acidity, and toxicity are chemical properties. Chemical properties can only be observed when a material undergoes a chemical change. In a chemical change, the arrangement of the atoms is changed. In the rusting of iron, for example, initially the iron atoms are arranged in a uniform lattice, and diatomic oxygen molecules are floating around in the air. After they react, the iron and oxygen atoms are no longer separate. They're chemically bound to one another in a specific ratio, 2 irons for every 3 oxygens. A new material exists that didn't before. Fe2O3, iron 3 oxide. A physical change, in comparison, changes only the state or the appearance of the material, but not the composition. The atoms or molecules that compose the material do not change during a physical change. Look at the 3 processes shown. Do they each represent a chemical or a physical change? The first image shows the sublimation of carbon dioxide. This is a change of state. The particles are CO2 molecules throughout. This represents a physical change. What about the second image, dissolving sugar in water? Initially, you have sugar molecules and water molecules separate. After, you still have sugar molecules and water molecules. The only difference is now they're evenly mixed together. The molecules had no change to their internal arrangement, so this is a physical change again. What about the third image, burning propane? This process starts with propane molecules, which are carbons and hydrogens bound together, and oxygen molecules. After, you have carbon dioxide molecules, carbon bound to two oxygens, and water molecules, two hydrogens bound to an oxygen. This time, the bonds between the atoms, the molecules and particles involved have changed, so this is a chemical reaction. Look back at our composition of matter flowchart one more time. What types of separation processes would be required to separate a mixture into its component substances? Only physical changes would be required because the components of a mixture are only physically mixed together. For example, how would you separate a mixture of water and sand? You'd filter out the sand. Pretty easy, and no change to the chemical structure of either component. What would it take to break a compound down to its constituent elements? That would require a chemical separation. The parts of a compound are chemically bound together, so you must use chemical processes to separate the atoms. Physical changes alter the state or appearance of a material, but not its chemical composition. Chemical changes result in the formation of new substances. Existing bonds between atoms are broken and new, different bonds form. In either case, in any physical or chemical change, there is an associated change in energy. This is the field of study known as thermochemistry. We will study thermochemistry in two parts, first in this unit, then again in our next unit. This unit is about physical properties of matter and physical changes. In particular, we'll study the thermochemistry and thermodynamics of changes of state. Thermochemistry, as I said a minute ago, is the study of the energy changes associated with physical and chemical processes. Thermodynamics includes thermochemistry as well as studying the entropy and free energy changes of these processes. In this unit, we'll also discuss the physical properties of gases in detail. Our discussion of solids and liquids will wait until late in the course. Actually, our last unit of the course.